We're very fortunate tonight to have Professor John Lewis, who is SSI's Vice President for Research, present a talk about Asia's route to the moon. Professor Lewis, as you all know, has been a distinguished advocate for the human settlement of space. And as you may also know, he's a distinguished scientist with a long list of books to his credit. And if any of you have any scientific inclination at all, you should definitely purchase a copy of the Physics and Chemistry of the Solar System. It is a fantastic book, and I know there must be a number of people here who would love to read it. So, John, it's all yours. Thank you.
The rule is you don't have to read my books, you just have to buy them. Okay, the subject of tonight's talk is what's happening on the other side of the world, what the prospects are and what the means are and what the plans are in Asia.
I've never used a Mac.
My wife and I spent a year in Beijing teaching at Tsinghua University, which bills itself as the MIT of China. And as a former professor at MIT, I take that with a grain of salt. In that position, I had the opportunity to give lecture series at the Chinese Academy of Sciences Center for Space Science and Applications, and also for the Chinese Lunar Missions Center, and got to meet a very large number of active Chinese scientists with interests in solar system exploration and even exploitation. So from that start, actually while there, I became engaged also with China Central Television, and I've actually been back to China 3 or 4 times since we returned from our teaching there for the purpose of narrating Chinese civil space launches on China Central Television. I did, So I did the Shenzhou 6, Shenzhou 7, Chang'e 1, and Chang'e 2. The latter two being the 2 Chinese moon probes. But wait, there's more. Is this what we're going to do then?
Yeah.
Okay, this is it. Those of you who do not have binoculars and are in the back of the room, tap the shoulder of someone closer to the screen and ask them what it says. All right, let's go on. I'm tired of looking at the Hubble deep space image. I never thought that would happen. Many people say the moon is the obvious place to go first, and here are the reasons. It's nearby. We have a quick signal turnaround, 1.3 seconds each way. So as Paul Spudis pointed out, this permits you to do real-time direction teleoperation of equipment on the surface of the moon. A short travel time for missions, about 3 days each way, although it's very easy to make it longer if you get velocitated too easily. And it's accessible to any country that has the ability to launch payloads into geosynchronous orbit. The incentive to launch geosynchronous satellites inadvertently confers the ability to send probes to the moon, Mars, and Venus, and even more distant targets. All right, that's the classical argument. What resources are available on the moon? Oxygen in common iron oxide-bearing minerals such as ilmenite, olivine, pyroxene. If you don't know those minerals already, don't bother to learn them now. Water ice in unknown abundance at the poles, and the distribution, of course, the total mass, the vertical and horizontal distribution is an ongoing story. We're learning as we inhale and exhale, new information's coming in. We've had several missions recently which have contributed to that understanding, and it's a great and fascinating story. Ferrous metals are available as a necessary byproduct of the extraction of oxygen from the moon. So why would these arguments be less compelling to Chinese or Indian space scientists or politicians than they are to those in the West? These arguments are not apparently overwhelmingly compelling in the United States right now because the focus of our future manned exploration program has shifted away from the moon. But these arguments still carry weight in other countries. And I should add here the last item on there, helium-3 fusion fuel from solar wind implantation. There are some minor problems with that. One is the lack of fusion reactors, and the other is the fact that the helium-3 distribution is exceedingly complex because it's, if you can take the figure for the highest known concentration of helium-3 and multiply that times the surface area of the moon and be staggered by the results, but that's a shell game. The distribution is very complex because of the impact history of the moon, where an area of the surface has been exposed to the solar wind for a long time and built up a lot of helium-3 in it, then gets buried by a layer of uneven thickness, and of course the surface of the moon isn't flat, so that irradiated layer does not conform to one single stratum. And if you found a helium-3 rich layer, how would you follow it? It's not like on Earth where you get nice parallel strata in sedimentary rocks, and no, it's very complicated. So I'm not convinced that this is economically viable. I have criticized these ideas in public enough times so that people begin to think I protest too much. Okay, let's move on. Now, there have been 88 lunar missions launched. I believe that's up to date. 63 of them successes by... We just had an eclipse. The moon has just emerged from eclipse. Soviet Union, United States. You remember the Soviet Union? Many of you are old enough to remember it. The Soviet Union had a very active planetary exploration program, and its successor, whatever you think of it, is now trying desperately to reconstitute some of that good karma that the Soviet program had. ESA, Japan, China, and India have all sent missions to the moon. Traditionally, we think of the exploration of the moon in terms of a sequence of steps, and China and India indeed are looking at very much the same kind of sequence. Let's go along here, talk about the 9 steps. First is flyby missions. There were 11 of them, most of them with undersized boosters, with undersized payloads, with ill-conceived mission plans, of which only 4 were successes. The number in parentheses is successes. There were hard impact missions. 10 of them were launched. Some of them became oceanographic probes. And 4 of them succeeded. Then we had unmanned soft landings. Remember, there's 17, mostly in the Luna series of the Soviet Union, of which 7 succeeded. Engineering test flights, 10. We can go along here to more interesting things. Stage number 5 was lunar orbiters. Interestingly, of 28 attempts to place satellites in orbit around the moon, 28 have been successful. Why? Because it's very much the same operation as putting a satellite in geosynchronous orbit. It's a much easier, much more familiar task than, for example, trying to carry out a soft landing on the moon. Unmanned rovers on the moon, 2 attempts, the Lunokhod 1 and Lunokhod 2, very imaginative names, both of which succeeded and succeeded in roving around and covering many hundreds of meters on the surface of the moon. 2 Soviet missions. Number 7 is unmanned sample return. We've had 6 attempts at that with 3 successes. The Soviet attempts to land vehicles on the moon initially were done before we had a good gravity map of the moon. And that means that they didn't know about the lumpiness of the gravitational field. They didn't know about the mass cons under the Mare basins. And that means that sometimes they landed on an imaginary surface that was well above the surface of the moon. And sometimes they tried to land on an imaginary surface that was a couple of kilometers below the surface of the moon. And neither one of these is a success-oriented strategy for those of you who are planning it. Then we have manned landings, 7 attempts, 6 successes. You've seen the movie. And then lunar bases, we're still at 0 there. And I have not listed any successes out of those 0 attempts. Recently, the complexion of the exploration of the moon has been changed by the introduction of new participants. 2007, the Chang'e lunar orbiter, which was basically not just a booster, which was developed for geosynchronous orbit, but the spacecraft bus was a modified ComSat bus. So Chang'e was successfully placed in orbit around the moon. Chang'e, by the way, was a Chinese moon, quasi-moon goddess who traveled to the moon in a flight of fancy. And you know how those ancient stories are. We won't get into that in too much detail because the engineering details don't stand up to scrutiny. In 2007, Japan also, I could tell you some other stories. In 2007, Japan sent the Selene orbiter with a surface penetrator probe. 2008, lunar reconnaissance orbiter with a polar ice probe. 2008, India sent the Chandrayaan mission, which, by the way, was a perfect example of international collaboration. It had instruments from several different countries, many different experimenters. It was a wonderful opportunity for people who had great instrument ideas to get their instruments flown quickly. And just a month ago, I was in Beijing announcing the Chang'e lunar orbiter. It also has the same spacecraft bus as Chang'e 1, but it has a more advanced camera system, and its purpose was it was put into an orbit that will give it good low-altitude oversight of several candidate landing sites for the future Chinese program. It will get down to an altitude of less than 20 kilometers above the mean surface of the moon. And on a body that has 12-kilometer mountains on it, you probably don't want to get much lower than that until you really, really know the gravity field of the moon in enormous detail. And that is an ongoing story, especially on the backside of the moon. Okay, so those are the recent lunar missions and planned lunar missions. 2011, the United States is planning a mission called GRAIL orbiter, which is a gravity field mapper, okay? This is designed to fill in some of our gaps and refine our knowledge of the lumpiness of the gravity field. 2013, China is scheduled to launch Chang'e 3, which is a lander carrying a rover. And the landing site selection for Chang'e 3 is going to be carried out over the next few months based on the Chang'e 2 imagery. In 2013, also, India is planning the Chandrayaan 2 orbiter with a lander and rover. I mean, this is serious stuff. We're talking here about funded programs. These are things that are likely to happen. Yes, schedules may slip. That happens from time to time. But these are serious programs. 2013, the United States will launch the LADEE orbiter, and then in 2015, possibly, I think that's probably best interpreted as the earliest possible date, Japan intends to launch the Selene 2 orbiter with probes to hit the surface and prospect ice. 2017, China has announced the launch of Chang'e 4, which is a sample return mission. It's pretty gutsy to have one flight to land on the moon before you attempt a sample return. But they are confident that their knowledge of the gravity field of the moon will be good enough by that time, by a combination of data from several different countries, that they can carry that off with some degree of confidence. 2019, ESA is planning a polar lander. And roughly 2025, both China and India have announced their intention of landing men on the moon. So how serious is that? How seriously should we take it? Stay tuned. Okay, here's what you've got to work with. China has the Long March 3A booster. Long March is spelled CZ in Chinese. They have the capability and the announced intent of launching small probes to Mars and Venus in 2013 and 2015. This does not require any significant changes to the booster. The biggest challenge is deep space tracking. China's tracking system was established for the purpose of tracking their manned space flights in low Earth orbit. So their thrust was tracking ships and getting good coverage, widespread geographical coverage around the Earth for tracking objects that were low and close and loud. Tracking objects on the way to the moon, spacecraft on the way to the moon, is more challenging because, of course, the inverse square law cuts down the signal strength impressively. And it's highly desirable to have at least 3 major deep space tracking stations spread more or less evenly around Earth's equator for tracking those missions. And for now, they have so to speak, a rented antenna site in Africa, and they have tracking ships that they hope will fill in the gap. India has the advanced satellite launching vehicles, what they use for launching their communication satellites. They have the capability of Mars and Venus probes in addition to the moon probes they've announced, but no announced plans to actually do it. Capabilities there. Japan has used the MV3 booster. They can also send probes to Mars and Venus, but the time scale is uncertain. They could send much larger and much more capable probes using the H2A booster, which is what we used to call a Titan class booster, but what's a Titan? The H2A is regarded as hideously expensive by the standards of space science programs in Japan, and they have pretty much forsworn the use of it. And Russia has made a great leap backwards to ICBM class boosters, the Soyuz 2 and the Zenith class boosters. They're sending a mission off to Phobos. Many of you who have long memories may recall the Phobos 1 and Phobos 2 missions that they launched, which turned into total fiascos not too many years back, and really apparently spelled the death knell of the Soviet Mars exploration program. Then they came back 7 years ago with an announced plan to use a proton booster to send essentially a carbon copy, or it's like the flight spare of the Phobos 1 and Phobos 2 spacecraft, to go to Mars, orbit around Mars, and land on the Martian moon Phobos and return a sample to Earth. A very ambitious and expensive mission, but they also can no longer afford to use the proton booster, which has 3 times the payload capacity of the smaller ones. So they're back to a more modest mission, and Phobos on the way, this Phobos mission on the way is going to be carrying a Chinese-made sub-satellite. So that will be interesting too. Next, please. Larger boosters are needed to do more ambitious things on the moon. Here are China's plans. The next generation booster will be the Long March 5 with a capacity of about 25 tons to LEO, 8 tons to GEO, to the moon or to Mars. That's sort of a Saturn 1 or a Proton or STS payload capacity. It's a pretty hefty payload, and that's a pretty serious booster. We'll talk about timescales in a minute. Then they have 2 more announced next second-generation launchers aimed at the lightweight and medium-weight LEO launch market, the Long March 6 and 7. They're too small to have any serious role in deep space exploration. Then we have the Long March 8, which would have 3 clustered Long March 5 first stages. And now look at what you're talking about. You're talking about 75 tons to LEO. This is getting up close to the Saturn V class. This is sort of a Saturn 3.7 class or something like that. This is a good-sized payload indeed, and you need something of this magnitude before you can start flying manned missions to the moon. And then we have the Long March 9, which has 5 clustered Long March 5 first stages. There we're talking, this is bigger than a Saturn V. It's what we used to call the Nova class back in the days before the Saturn family was truncated with the Saturn V. That's 40 tons to escape, you know, that's very serious stuff. Now, about the utilization of these boosters, we would have to know what China's basic plan for manned lunar exploration was. Do they plan Earth orbit rendezvous? Do they plan lunar orbit rendezvous? Or do they plan direct ascent? They haven't said yet. And I think with this assortment of boosters, they actually have some choices still open. And the fact that I don't know the answer may mean they don't know either. But we'll see. Next, please. Availability. The first test flight of the Long March 5 is in 2014. They plan to use it for the first time in deep space for the moon sample return mission in 2017. That booster could also be used for testing a manned lunar lander in low Earth orbit in much the same way that the Saturn I was used to flight qualify the LEM before the LEM was ever let near the moon. And will also be used to launch a space station core module in 2020. Just a word to avoid confusion here. In January of next year, China is going to launch a small space station module. It's in the 8-ton class. It's basically putting up something that's about the same size as a Shenzhou spacecraft. And it will be put in orbit and then eventually manned. There'll be rendezvous and docking with a Shenzhou, which will carry 2 or 3 taikonauts to rendezvous with it and constitute a small space station. But this thing here, this 2020 space station core module is 3 times the size of the Shenzhou 8 module, so it's much more substantial. The Long March 8, 2020, Long March 9, 2024, and it'll be used in some manner for a manned lunar landing around 2025. Direct ascent, lunar orbit rendezvous, Earth orbit rendezvous. Flip your coin and make up your own mind. Okay, man on the moon. A new space race, question mark. The United States is not engaged in a space race with the Soviet Union, China, or India at present. And I hope it remains that way. Space races are not a way of optimizing the efficiency of the use of resources. They're a way of maximizing the amount of resources you use. They're very expensive, and let's try to avoid them. But India and China both have the moon in their sights, and India and China have a lot to prove. They are vying for the visible leadership of the third world, and there's a huge political element here. Of course, the Apollo program had no political purpose. But that competitive disease that we shared with the Soviets for some years still exists, and it's now between China and Japan. China and India. No, Japan does not have its sights on sending men to the moon. Okay, now let's go to Mars. There have been 41 Mars missions launched with 20 successes. That's a much less favorable number. If you read National Enquirer, you'll know that the Martians resent the intrusion and have been shooting them down regularly. Plausible. Funny you should ask. Now, Mars, like the moon, has a so-called logical sequence of stages of exploration. Let's run through those stages here. Well, why go to Mars? It's the most Earth-like planet. It's the most user-friendly. It has an atmosphere. It has ice. It has not just buried ice at the poles, but it has lots of ice, and that ice is well established. It's in very large quantities. In fact, permafrost probably covers more than 50% of the surface area of Mars, down to a significant depth of hundreds of meters to a couple of kilometers. It once had abundant water, and that's what this background slide is intended to remind you of. When Harold Urey saw these pictures, he says, well, it's either water or vodka. I'm an adherent of the water theory, although vodka does mean little water. So life may have begun on Mars. I'm not citing the evidence from meteorites, which I do not think proves anything at all. But I'm saying that the early history of Mars, a water-rich environment, thicker atmosphere, a stronger greenhouse effect, may have been conducive to the origin of life. That's pure theory. It is not a prediction. It is not a conclusion based on evidence. It's pure theory. There. So you just got what you paid for. Fossils, even life, may be present now. Maybe. See? Maybe. And rockets can deliver more payload to the surface of Mars than to the moon. How can they do that? By aerobraking, by using the atmosphere of Mars to slow you down on the way in. Furthermore, you can easily combine your trip to the surface of Mars with a visit to Phobos and Deimos. Why would you want to do that? Well, because they look like carbonaceous asteroids. We don't see water in their reflection spectrum, but on the other hand, they've gone through a very lengthy and tortuous experience of heavy cratering. And there's an oddity about the gravity field of Mars, is that in the vicinity of the satellites, the gravity field is so steep that impact ejecta from Phobos and Deimos goes into a nearby orbit around Mars and gets swept up again. So the surface materials we see on those two satellites are probably things that have been on and off of those satellites multiple times, have been shock heated repeatedly, and dried out. What about the interiors of Phobos and Deimos? How much water is there? I could go out on a limb here and I say it's probably quite a bit. How much is quite a bit? Millions and billions of something in the appropriate units. So don't rule out the possibility that Phobos and Deimos are great places to find water, providing you get down through that shock-heated and reheated and reheated regolith. Okay, next. Accessibility of Mars with existing boosters. Russia will be using the Soyuz to Fregat combination. The Proton is always there in case suddenly their oil reserves should increase and their foreign sale of petrochemicals would produce a revenue stream that would make it more feasible, but right now they can't afford it. The Atlas V, the Delta II are available in the United States. China has the Long March 3C, which is their existing, the one they've been using for their geo and lunar probes. India, the ASLV, as I mentioned before. Japan, the MV3, and the hypothetical H2A, which they say they can't afford for deep space missions, and ESA has the Ariane 5. So there's a lot of launch capability here on Earth, and it's just a matter of taking advantage of it and paying the price. Okay, on Mars, resource targets. Rocket propellants can be made from the atmosphere. You inhale carbon dioxide, pass it through essentially electrolysis through a ceramic membrane, and split it into carbon monoxide and oxygen. Liquefy the carbon monoxide and oxygen, and you have rocket fuel and rocket oxidizer, a propellant pair. The performance of a carbon monoxide oxygen engine is inferior to that of cryogenic propellants because you're already using carbon that's half burned, but it's sufficient to get off of Mars in a single stage. So there's a lot of interest now. We actually, in our Space Engineering Research Center at the U of A, we built an experimental device to be landed on Mars and to demonstrate the production of carbon monoxide and oxygen. Unfortunately, that was prepared for flight and ready to go just before two successive Mars probes crashed ingloriously, and it was removed from the flight manifest and has never flown. Life support materials can be made from ice and permafrost. As I mentioned, the permafrost is very widespread, 50–55% of the surface area of Mars. And the ice, of course, on the polar caps. Phobos and Deimos, similar to carbonaceous meteorites, and if they are indeed as wet as I suspect they are inside, then propellants and life support materials can easily be made out of that ice too. The only promising export from Mars is scientific samples. and eventually Martians. But we have to provide the Martians. Okay, now those 7 steps of Mars exploration. Flybys, 10 have been sent. 3 were unqualified successes. Landers, 12 have been sent. 4 successes. Orbiters, 17 have been sent, 11 successes. Rovers, 4 have been sent with 3 successes. And sample return, never attempted. Manned landing, never attempted. And Mars base, never attempted. So at least we haven't any failures there on our scorecard. Recent Mars missions, Mars Odyssey 2001, a NASA mission. Orbiter failure, nothing. Spirit, and also notice down here, Opportunity, are essentially twins to rove around on the surface of Mars and take beautiful, incredible photographs. Mars Express orbiter with a subsatellite, which was an intended lander, Beagle 2, built in England. Launched from, this is a European mission, launched from Baikonur Cosmodrome aboard a Soyuz 2 frigate. Why? The price was right. And then we have Mars Reconnaissance Orbiter, MRO, 2005, and the Phoenix mission, another spectacular success in 2007. There are a lot of USAs on that list. That list is going to get much more complex. There are going to be a lot more players over the next few years, I guarantee it. Okay, next, please. Planned Mars mission. Phobos Grunt, not grunt, grunt. Grunt means ground. It means it's a lander, okay? With the Yinghuo orbiter, made in China, and to be launched, supposedly, next year. Now, this is a much delayed and much redesigned mission. Any kind of fiscal stringencies or any kinds of hardware problems could cause that to slip to a later launch date. But with Mars missions, your launch dates are about 2 years apart, so you don't want to slip. Then we have a Curiosity and the Mars MSL rover, also 2011 launch. As you can tell, there's a good Mars launch window in 2011. And in 2013, MAVEN orbiter, which is upper atmosphere studies. And then possibly in 2013, China's first Mars probe. They have said as early as 2013. Traditionally, when they have said something like that, they have actually performed. They don't want to be embarrassed by naming unrealistically early launch dates. They don't reveal a lot, but what they reveal you can pretty much rely on. India plans a Mars probe in either 2013 or 2015. I'm guessing 2015, using, again, the same ASLV launch vehicle. And ExoMars, which is a joint ESA-NASA mission, is looking at the exobiological interest of the planet. 2015, okay? Okay, the nations that have expressed interest in manned Mars exploration have expressed interest in it. This is not a commitment. United States, several ESA member states, Russia, Japan, China, and India. I even found one press release that says Malaysia is interested in landing men on the moon in the same time frame. But since they have no program and no money, I tend to push that off to a little farther into the future. But there's the makings here of a great traffic jam. Next, please. All right, let's finish up the inner solar system. We've got Mercury, we've got Venus, we've got the Moon, we've got the near-Earth asteroids, and we've got Mars and Phobos and Deimos. All right. Exploration of Mercury, only 2 missions have been flown, both by NASA, Mariner 10, the MDN mission, with 3 Mercury flybys with very similar geometry because of the harmonic relationship between the orbital period of MVM around the Sun and the orbital period of Mercury. And the fact that Mercury is spin orbit locked onto the Sun in a 3-to-2 resonance. Yes, I could explain it, but not now. Then we have in flight, Mercury Messenger, which has been using the gravitational interactions of the Earth and Venus to pump its orbit into Mercury, is going to be arriving at Mercury, ready for orbit insertion in January. So January could be a very, very interesting time. A Mercury orbiter can provide us with maps of the 40% of the surface of Mercury that we've never seen up close. And it could be very interesting indeed, not to mention measuring the magnetic field of Mercury down close and measuring the gravity field of Mercury to see how lumpy it is. The missions that have been flown, MVM, showed that the Mercury is strikingly similar to the moon. In fact, if you take a photograph of a small area of Mercury, you'd have to do some pretty sophisticated measurements and calculations to even be sure that it wasn't the moon. The surfaces look very, very similar. There's no air or water, but there is polar ice on Mercury. Polar ice on Mercury. It was discovered by radar from Earth when they were looking at Mercury when it was slightly tipped so that one pole was toward Earth, and they found that the brightest spot on Mercury was the pole. Very unexpected result. Gordon Pettengill came into my office and said, "Could this really be ice?" And the answer appears to be yes, now that we've seen the moon with similar geometry, similar surface conditions. There it is. And of course, covered with craters. One planned mission, joint mission of ESA and JAXA, the Japanese exploration agency. The Bepi Colombo mission, I had the pleasure of actually meeting Bepi Colombo, who is a real person. This is not an allusion to Christopher Columbus, misspelled badly. Orbiter with launch in 2014 and Mercury orbit insertion in 2020 because, once again, they're using repeated flybys of Earth and Venus to torque the orbit slowly into Mercury's distance from the sun. You know, it's not hard to send a spacecraft by Mercury. The problem is if you go direct, it comes in from Earth's orbit and is traveling so fast as it goes by Mercury that it's almost impossible to stop. So you have to do fancy celestial mechanics to move the orbit in stepwise so that you can afford to put it in orbit. Next, please. Oh, yeah. Why explore asteroids, he asks. If you don't know the answer to that, go out there and don't just buy Mining the Sky, but read it, okay? Why explore asteroids? They're easy to get to. How many near-Earth asteroids are there that are energetically more accessible than the surface of the moon? In other words, a given rocket booster could land a larger payload on that asteroid than on the moon. How many known near-Earth asteroids are easier to reach than the moon? Of all sizes, from the entire list of known near-Earth asteroids, about 1,700. And easier to land on than most of those are Phobos and Deimos. Much easier than landing on our moon. Isn't that weird? Well, the answer, of course, is that you have to add up all the contributions, all the energy contributions of each stage along the way. But when you get up close to Phobos and Deimos, it costs you less than a nickel to land because they have virtually no gravity. So you sort of rendezvous and dock with it and set down gently. On our moon, I do not advise that approach. Easier to return from than the moon or Mars. That means the return delta V requirement, velocity increment requirement, is very small, in some cases less than 100 meters per second. And as we were coming in here, I saw at least one vehicle in the parking lot out there that is capable of 100 meters per second. So I don't recommend sending it to Mars. And for the near-Earth asteroids, there are daily launch opportunities. Daily. Whew. Untold riches. I'm going to be passing the hat at the end of this meeting. Untold riches of metals for building materials, water for life support, and for oxygen debris, propellants, and so on. That's a long story, and I won't get into it now. some are a threat to Earth. We could turn a liability into an asset by accessing them. Okay? What resources are present on them? Abundant ferrous metals, chemically bound water, and buried ice. A number of the near-Earth asteroids are probably extinct comet cores that have dehydrated regoliths on the surface and have a large reservoir. Their interiors may be 50 or 60% ice. Which ones, you may ask? Well, I could give you a list of candidates, but we don't know which ones have all that ice in them. But we have seen one comet, Wilson-Harrington, 1949, that is now known as an asteroid. It was a comet when it was discovered. It's now an asteroid. If we have seen one transvestite comet I knew you'd laugh. That's Rick. If we've seen one happen in this century, how many others have done it? The bodies in the near-Earth population have orbital lifetimes that average about 10 to the 7th years. And if we just have one every 1,000 years that behaves like that, that's a staggering opportunity. A lot of ice there. And once the surface gets baked clean of water, the loss rate essentially goes to zero because you've got a lag deposit of fine dust, which is black and opaque, does not let sunlight in, and is a lousy conductor of heat. So the sun essentially ceases to warm the icy interior, and it has a very, very long survival time. There have been about 24 thermal evolution studies of short period comets, and they all predict that it should be a common outcome to produce a black, sooty-looking, asteroid-appearing body that has no visible cometary activity when most of the interior is still ice. Okay, other volatiles for life support: carbon, nitrogen, sulfur. Remember, I think the most important limiting resource for life in the solar system is nitrogen. You go to Mars and you'll quickly bemoan the rarity, the scarcity of nitrogen in the atmosphere of Mars. It's a serious issue. And many precious and strategic metals that are very rare on Earth, well, they're not actually any rarer on Earth than they are in the asteroid belt. It's just that on Earth, they're in the core, and that's an inconvenience. Isn't that right, Mark? Okay, let's go on, please. Here's 3 of the visited asteroids to give you some idea of what they look like. They have a softened look on the surface that suggests that they have a significant regolith. The wisdom before we started getting up close to small asteroids was that the small ones should be bare monolithic rocks with no regolith, but that is approximately wrong. Approximately wrong, yes. So orbiting around one of these things could be an exciting experience. Think of the shape of the gravity field. Okay, we have a little experience with that, and it's quite a ride. Next one, please. Tilda, by the way, is named for the street out there. Progress in exploring asteroids. We've had 3 dedicated missions and 2.5 successes. I'm counting Hayabusa as a half a success. Great expectations. Galileo also flew by Gaspra, Ida, and Dactyl satellite, Ida satellite. Back in the 1990s, in an earlier millennium, the NEAR spacecraft did a flyby of Matilda, orbited around Eros in 1997. Deep Space One did its flyby of Braille in 1999. And Hayabusa just got back last summer with empty pockets, apparently. There's been remarkably little news out of Japan about what they found or didn't find aboard the Hayabusa return capsule. Okay. So Russia and China are doing a quasi-asteroid lander by going to Phobos. Phobos is a very asteroid-like body. So in 2011, we expect the Phobos Grunt lander on Phobos. And the sample return to Earth was part of the original plan when it was a Proton launch. And curiously, it's hard to find them explicitly disavowing it for this much smaller mission. We'll see. I doubt it, but we'll see. I doubt they can do it, but we'll see. And in 2013, or probably later, Hayabusa 2, another attempt at a sample return. And once again, the H-2A booster is too expensive, and Japan is fishing around for a partner on that mission, possibly someone who can provide cheap launch services. So there are opportunities everywhere I look for international collaboration. Shall we go on here? Okay, human exploration projects. Mercury, Venus, forget about it. Next. Moon. Moon exploration will resume before 2025, but the US will not join the race. So that's China and India. Manned missions to Mars, the first man tripped by the US before 2025, question mark. Why 2025? Because some people say it. Why the question mark? Because I don't believe it. Okay. By the US. Now this is a perfect candidate for international collaboration. It's a big, ambitious, expensive mission. It's doing something that is of enormous interest throughout the world. Don't you think we could get somebody to cooperate with us? All we have to do is we have to be good collaboration partners. Oops, oops, oops. Some of you who remember the International Space Station, oh, never mind. This is supposed to be upbeat. Then the question mark here, the new kid on the block, nearby asteroids. Tom Jones, who is, as you might guess, a former student of mine, is a strong advocate of manned missions to flight qualify Mars-bound manned hardware by going to near-Earth asteroids. You can test fly every system, you can exercise all the propulsion capabilities without ever getting deep in the gravity well of another planet. Okay? Furthermore, you can scope out some asteroids which are in orbits that take them from perihelion distances close to Earth's orbit to aphelion distances near the orbit of Mars. These are not, I think the phrase traveling hotel is overly graphic, but they are at least radiation shields. You can fly along with one of them, and if the sun acts up, you can get in its solar wind shadow and be protected. Also, it's an opportunity to land on it, to take samples, to do simple seismic studies on it, to find out just exactly what it's made of, and once we know that, we can figure out how to use it. If one of those asteroids happens to have a high water content, then Mars-bound missions could actually produce their own propellant while en route to Mars. They could be launched with empty fuel tanks. And launching with empty fuel tanks means that you can roughly triple the useful payload of a Mars-bound mission. Okay, and it also gives you enough hands-on experience with near-Earth asteroids to prepare for planetary defense missions. The planetary defense argument is considered intriguing in China, but they don't know quite what to do about it or whether they should do anything about it. In much the same way that the economic potential of the moon is considered intriguing, but they're not quite sure what to do about that either. Next, please. Mission that might have been. In 2004, 2005, we were doing the Phase A study for the Moon-Mars program of a previous administration. There were about 12 different competing contractor teams working on this, looking at the overall mission plans and making proposals for ways to sharpen the capabilities of specifying what the minimum hardware necessary for the mission really was, talking about candidate mission profiles. It's all very interesting. I was the chairman of the advisory team for the Raytheon group at that time, with Tom Jones batting cleanup. And we produced quite a nice story, and we took it to our program manager at NASA headquarters, who shall go nameless here. He knows where I live. And we proposed the inclusion of near-Earth asteroids in plans for manned Mars missions. And his response was, asteroids have been baselined out. And my knowing Dan Golden was the administrator of NASA, my ear sort of pricked up and I said, by whom and why? And for the next 5 minutes, he uttered a series of disconnected syllables which did not succeed in answering either question or even in acknowledging that I had asked them. He apparently had made that decision on his own merits. Oh, yes. And Mike Griffin apparently didn't know the answer to that one either, and he thought it would be just a great idea to get asteroids into the plan. But anyhow, so we were excluded from Phase B on the grounds that we were not responsive to NASA's priorities. Be not the first on whom the new is tried, nor yet the last to lay the old aside. Alexander Pope, an early expert on space technology. Prospects for international cooperation. China and Russia are actively cooperating on lunar and planetary missions. You will see more of it in the future. There were some very rocky times in Chinese-Russian relations, including some studied insults of the leaders of both countries by the leaders of the other country. Some great stories there, all of which are true. And we can expect that to continue, and we can also expect China and Russia to host foreign investigators on their missions as a political gesture, as a form of getting other countries involved and helping them into space. Whether they'll get the best instruments out of that collaboration remains to be seen. China and ESA have had cooperative Earth orbiting missions. Double Star is an excellent example of that, the magnetospheric survey, synoptic study of the outer magnetosphere. And India has flown US and ESA instruments on Chandrayaan-1 and will continue to do so. It's in their best interest, and it's in the best interest of instrument builders in Europe and the United States to foster collaboration of this sort. More power to them. Next, please. China is still rankling over the International Space Station. The story, as I heard it, was that Reagan invited China to participate in the ISS, and China said, no, thank you, we'd rather do it ourselves. However, the Chinese, translated from Chinese into English, their version of the story is quite different. It was that they expressed great interest in participating in ISS, but they were blackballed by the Americans. It's funny how things look different when you look at them from opposite sides of a big ocean. Manned Mars missions are so expensive that sharing the work and cost is wise and probably even essential. Let's hope that we can swallow our pride to the point where we can actually collaborate meaningfully. India plans manned spaceflight before 2015, but with whose technology base? There's a common conception that the Chinese manned spaceflight was entirely done with Russian hardware. Wrong. There were two specific items of Russian hardware that they used. It was Russian airlocks and Russian spacesuits, and they bought them. The rest of the hardware was homegrown. China-India collaboration is unlikely for geopolitical reasons. Interesting. And finally, there's Khrushchev's law. You all remember Khrushchev, and yes, I did spell it correctly. Khrushchev said, if two nations want to collaborate in space, then they face an interesting challenge. The nation which is ahead in some critical area of technology will not want to share their lead with the other country. Conversely, the nation which is behind in some critical area of technology will not want to be embarrassed by admitting that they are behind. Therefore, international collaboration is impossible except between two countries which are perfectly equal in everything, which never happens. So Khrushchev's law is a reflection of a mindset. It's not a law of nature. It's a psychological principle, and we hopefully may be big enough to get beyond that. Conclusions. India has a goal, sending men to the moon. China has a plan. At the moment, my money goes with the Chinese effort because they have spelled out step by step how they're going to do it and what hardware they're going to use and when they're going to be flying that hardware and when it will be available. That has a lot of verisimilitude to me. And does India intend to go to the moon, send men to the moon? Yes, they do. But the cost of doing it is immense. And unless India can form meaningful partnerships to share the cost and share the technological burden, I don't think they're going to be able to compete on the same playing field with China on the way to the moon. Space resource interest in China and Japan extends to lunar helium-3 and no farther. It's the energy issue is the big attractor there, the strong attractor. Are they serious enough about it to actually send dedicated missions to try to map the helium-3 distribution and do trial extraction of helium-3 from the regolith? Not yet. No flight plans. So in terms of our potential for collaboration with them on helium-3 issues, I think they probably would want some kind of serious inducements to join a collaboration to research this area, such as money or a free ride. Space colonization is not on the table for either China or Japan. They don't talk in those terms. In fact, China has a very interesting mantra that they repeat whenever you talk about technological issues. They say their goal is, they always say, their goal is to catch up with the West. I have never once heard a Japanese or a Chinese scientist or engineer say that their goal was to lead the world. Never once. They want to catch up with the West. And I have this picture of this big freight train barreling along the tracks, and there's a little Japanese or Chinese hand car coming along behind. They're pumping like mad, and their whole goal is to catch on to the rear bumper of the train and coast with it. Trying to establish a position of leadership is very expensive. It requires declaring a competition, declaring a race, and China is constitutionally unsuited to doing that. Okay. Chinese manned spaceflight is a function of the PLA. This is not the Palestinian Liberation Association agency. The People's Liberation Army. I don't know if you're familiar with the structure of the military in China, but the People's Liberation Army is what we call the Defense Department. It's the equivalent to the Defense Department. They have the People's Liberation Army's Navy and the People's Liberation Army Air Force, which are branches of the PLA. So all rocketry is the proper purview of the PLA Air Force. All their launch crews are 100% military. And the people who run their manned spaceflight program all wear uniforms, which are heavily adorned with brass and braid and other weighty things and metals. There is no question that the program is owned by the People's Liberation Army. And in the changing political map of China, where democratization is the buzzword of the year, has been since the 18th Party Congress. I was there at the time of the 18th Party Congress. And because I spent so much time at their television stations, I got to talk to their political commentators and their news anchors. And I said, what impressed you about the Party Congress? One, the frequent and sincere use of the words democracy and democratization. But, they cautioned, don't think that they mean American-style democracy. Their mental model is Japanese-style democracy with a strong one-party system with grassroots participation in that party to bring diversity of opinion up through the ranks. They still want that one-party system. Guess which party? No, not a fair question. The Green Party. Yes. So, every person you see in the videos from the launch center, everyone's wearing a uniform. It's all a military activity. Oh yeah, back to the 18th Party Congress. The other thing was that during that Congress, they had purged all the members of the Politburo and the Central Committee of the Communist Party who had living memory of the Long March. They were all gone. Those were the Maoists. In fact, they're probably still Maoists in retirement. And they were replaced, as a rule, by Shanghai businessmen whose lifeblood is trade with the West. Okay. Don't think Maoism is completely dead. 900 million Chinese don't know there's anything else because they live in the rice paddies. They had minimal schooling. Chinese children, a Chinese family that wants to send a child to school has to pay for it. Did you know that? You can't send a child to school in China unless you pay for his education. So if you're a subsistence farmer who's barely producing enough rice to feed your family, you don't have the money. You're not in the cash economy. You can't send your child to school. Or you make gigantic sacrifices and eat nothing but rice and water and send one of your kids to school. Now, if you live on a farm, if you're a farmer, you may have more than one child. If you have a girl first, you're allowed to try a second time to have someone to work your farm. Okay? So it requires gigantic sacrifices for people from the rural areas to go to college. And when they do, they arrive at college completely out of step with the intellectual climate on Chinese college campuses, which is highly progressive, highly experimental. They even know about the internet. Although freshmen at Chinese universities, when we were there, were not allowed access to the internet. It was considered to be too great a shock for their systems. So they have their own lore about the war against the United States aggressive invasion of Korea. They don't know they were fighting the United Nations. They don't know that there were 20 countries on the other side. They don't know that North Korea invaded South Korea first. They don't know any of these things. But once they get access to the internet, they start wandering around and reading different sites, and they find two amazing and distressing things. One is that Western authorities may disagree on subjects and actually get those disagreements published and broadcast. And the other is that nothing that's available in the West bears out anything that they were told in school about some of these historical events. So it's a very interesting country. It has enormous potential for economic success and for civil unrest. While we were there, the Chinese Interior Ministry announced publicly that in the previous year, there had been 35,000 incidents of mass public protest and civil unrest in China. They announced that. The world is changing. And the world is changing more rapidly in China than anywhere else. So keep your eye on what's going on there. Yes, you will see some very reactionary things said by leaders in the Chinese government. But I guarantee you that their purpose is to appease the PLA. If Western-style democracy were instituted tomorrow in China and everyone could go to the polls and vote, China would become Maoist overnight because the 900 million peasants who don't know anything else greatly outnumber the 450 million, 430 million urbanites who do know something else. Okay, so there is a space race, and it's politically and public relations driven, and we're not in it. The good news, the solar system and its riches are not being coveted by any government. Private economic initiative has an opening and does not compete or conflict with any stated governmental ambitions. Now, of course, once you have a cash cow, there will people will want to borrow it, tax it, steal it, kill it and eat it. You know, this is the cow that laid the golden egg. So my bottom line after all of this is, for you folks, you entrepreneurs, you would-be space cowboys, the sky is no longer the limit. Go for it. It's there in astronomical quantities. It's there for the taking, and we can do it using 19th and 20th century technology to a large extent. Sure, we can improve on it. Sure, we can. But we don't have to invent everything from scratch. We have this huge body of knowledge that we've gained about the solar system in the past few decades, and that we've learned about processing techniques and about propulsion techniques and so on. All we need to do is look over our huge body of knowledge and put the right pieces together and assemble something that may look more like a tiger and less like a giraffe, with coherent pieces that support the goals that you really want, which is, you know, our first goal is really not to colonize space. Our first goal is to make space so economically attractive that it will colonize itself. Okay? So go and do it.
Thanks very much, John. Do you want to take any questions? The audience, I'm sure, has got some.
You choose the people.
Parabolic arc.
Yeah, couple things. I talked to somebody involved in Augustine Committee thinking, and they were worried that the moon base that NASA was planning would be another sinkhole like ISS. And do you see potential for the way the U.S. is doing it being more of a better base, where we have a commercial operation in low Earth orbit that can go beyond to the moon and support what NASA wants to eventually do there?
Well, yeah, certainly being able to provide NASA with the things it needs is a very desirable thing to do.
Yeah.
I don't know where to go. I mean, that's worth probably 2 or 3 hours of answer, but yeah. Look, the fact is that the world is different. The fact is that China is different, and that China is in its adolescence politically. It's undergoing rapid change. For us to think about collaboration and think about ITAR in the same way that we did 10, 20 years ago is self-defeating. We need to make some adjustments ourselves. We need to think in terms of how to make collaboration attractive to other countries. Holy cow. Yeah.
The ISS is there.
Yeah.
It's got a bunch of people on it. What could we use it for?
If that question had been asked before ISS was designed, there would be an answer for it.
Mark, you have a question. John, what feeling did you get as to the views of the Japanese, the Indians, and the Chinese on solar power satellites?
Solar power satellite. There is interest. I've had 2 or 3 conversations with high-ranking people in China, in the Chinese Academy of Science, who do not make the decisions, the policy decisions, but who are advocates of solar power satellites, and at the very least of demonstrations of solar power satellites. And also one who's at the Center for Space Science and Applied Research of the Chinese Academy, who thinks it's time for a serious, new, fresh look at helium-3 nitrogen extraction on the moon. I think in Japan, the feelings are very much the same way. And some of these things that are logical next steps are pretty expensive. So I think Japan would be delighted to participate in either one of those activities, providing they could share the expenses.
Aubrey. One of the statements Elon from SpaceX has made is one of the reasons he started SpaceX is he wanted to do a private Mars exploration mission and the launch cost was too high. How would China see an entirely